Yeah, I think where um, we left off discussing the reasons, right, for forwarding and blocking on certain ports whenever we're using a spanning tree, right? Um, the next thing we need to dive into, right, is what is the deciding factor when it comes into choosing your port roles, right, and flipping their port states, okay, along with choosing your root switch and your designated switch, right? All your types of switch within your spanning tree. Okay. So one of the things we do need to discuss is the spanning tree bridge ID and a hello BPDU, right? So if we're talking about the algorithm, right, the spanning tree algorithm, uh, with the it starts out first whenever we plug all these switches up with an election of one switch to become the root switch, right? Okay. So with that, we need to understand what a bridge ID is, right? What is a bridge ID? Well, a bridge ID from a technical standpoint is an 8-byte value unique to each switch, right? So that bridge ID it consists of a 2-byte, right? Because it's 8 bytes, right? So a 2-byte priority field and a 6-byte system ID, right? With the system ID being based on the burned in the global MAC address for that switch. Okay. So spanning tree, sorry about that. Spanning tree is going to use the priority number, right? The 2-byte priority field, and the 6-byte system ID, aka the MAC address for the entire switch, to determine, right? Determine which switch is going to be unique to one another. No switch will have the same bridge ID. Okay, every MAC address is going to be the same, right? Um, and again, these with these, we have the bridge IDs or what have you, right? Switches, as soon as they connect to each other, they have messages that they send to each other, right? And these are called bridge protocol data units, aka BPDUs, right? Okay. These BPDUs, right? Within spanning tree, whenever they're sent out, right, they're called configuration BPDUs, right? Switches use that to go ahead and exchange information with each other. Now, if we're talking about 802.1d, right, old spanning tree, okay, the only device that sends out configuration BPDUs is the root switch. Okay, keep that in mind, guys. All right. Now, there's plenty of different BPDUs, right? The most common one that I want you guys to keep in your head and to know, like the back of your head, is a hello BPDU, right? What it does, it has details, right? And I'll talk about those detail fields, and I actually got an example for you guys so we can go ahead and take a look, right? So it's going to have, the sending switches, maybe bridge ID. It's going to have its own bridge ID, right? And it's going to have many fields that list information about itself and others, right? Let's talk about the fields within a BPDU. Okay, let's uh let's back this up a little bit. Here I have a packet capture, right, of a BPDU, right? Let's go ahead and pull this up. All right, so now, and this is a key topic within the exam, so you guys need to know this, right? There are 4 fields that you need to understand within a BPD, right? One, the root bridge ID, right? The bridge ID of the switch that the sender of this hello currently believes to be the root switch. So, how do we find the bridge ID within a packet capture? Okay, so we go within, right? We go within the BPDU, right? Because this is what we're looking at. And we go ahead and go into root identifier. This is the root bridge ID. Okay. Why is it the root bridge ID? Let me go ahead and get my pencil. Okay. So, oops, sorry about that, guys. So it's the root bridge ID because, again, I told you guys, the bridge ID consists of what? 2 bytes for the priority, 6 bytes for the field, with a total of 8-byte field. So we have the priority right here. Okay. And we have the bridge ID. Okay. which of course, and I apologize, we have the system MAC address, right? Also referred to as the system ID. But this is what we have, and this is the global MAC address, right? If you ever look at a switch, right? If you ever log into a switch and you try to find out its global MAC address, right? You'll see its global MAC address. Maybe you could do a show version. Maybe it'll tell you a show inventory. That'll go ahead and show you. Then you look at maybe you want to find out the MAC address of each interface. Each interface of the switch is going to be a copy of the global MAC address with a few changes at the end of that of that of that system ID, right? Of that MAC address. So maybe it'll change roughly like right here. Okay. But again, it'll be part of the same switch if you ever look at that. All right. So let's clear this out. Let's take a look. Let's blow up these fields, right? Because I like details. Right. So we're looking at, and let me get this pencil, right? We're looking at the root bridge priority, right? Because you could always blow it up, right? We got the priority, okay? 2-byte field. We have, and let me enclose this, we have the system ID. So the system ID, okay, it includes the, and let me do this. Let's do that, okay? That priority number is always going to be associated with the system ID extension, okay? The system ID extension correlates with the VLAN ID, okay? So if we're talking about this packet capture that we have, the priority is 32768, right? Associating with the VLAN 100, right? Okay, so with this system ID extension, we're going to add, right? We're going to add 100 to the priority. So to be 32,868. Okay, all right. So when it looks at that, it's going to say, okay, who has a better priority, right? Let's say 2 or 3 switches have the same priority. Okay, right? And I'm jumping ahead a little bit, but I want you guys to make sense of it. If there is a tie within the priority, we're going to jump down to the tiebreaker, which is that MAC address. Why? Because every switch is going to have a different MAC address. Okay? Okay, let's jump and let's look at the next field that you'll need to know for the exam. Okay? That will be the bridge identifier, right? The bridge ID. Okay? And this is the sender's bridge ID. Okay? And this is the bridge ID of the switch that's sending you the BPDU. Okay? So let's take a look at the same thing, right? We have the priority. We have the system ID extension, right? If you look at the switch, it'll say sys-id-ext. Okay? So we're taking a look at this, and we have that. And then, of course, we have that MAC address, right? What else is within this BPDU that we need to know, right? One field that you need to know for the exam is the sender's root cost, right? And this is the cost between the switch and the current root, okay? Where can we see that? Right here. Let me collapse this so you guys can see it. Here we go. This is the root path cost. You guys will need to know this for the exam. So the sender's root cost is right here under root path cost, okay? Next, let's go ahead and clear all drawings. The last field that you would need to know within a Hello BPDU is the timer values on the root switch. Okay? So you're going to be sent a couple of things, right? Port identifier, BPDU flags, right? Of course, like we spoke about, configuration BPDU, right? But what are these down here? What are these, right? These are timers, okay? And this is going to include, right, your hello timer, right? This is going to include your max age timer, and this is going to include your forwarding delay timer. Okay? All right. So with that being said, of course, you guys learned about that a little bit before, right? Let's talk about electing a root switch. Okay, let's put that down. Right now, again, how does switches within a topology choose that root switch? It is based on that bridge ID. Okay, let's pull up the switch. Right, if we're looking at this switch, let me move this right here. Right, let's look at this bridge ID. Okay, we got this pulled up. And what's an easy way we can go ahead and look at the bridge ID? Let's do a show spanning tree. Okay. All right. So we'll just need one for now. So let me exit out of this. There we go. All right. So bridge ID, right? It's telling us this bridge. We can take a look at a couple things. We know it's running 802.1D, right? Old school spanning tree. Okay. We have the root bridge ID, right? We have the priority, right? 327.69. We have, of course, the MAC address, right? Ignore this for now, right? But we also have what? We have our hello timer, we have our max age timer, and we have our forwarding delay. We also have the bridge ID, right? For this VLAN, right? We have the priority, right? And we also have the system identification extension, which is VLAN 1, right? So the priority for this VLAN, right, is 327.61. By default, it's always going to be 327.68 unless you change it, okay? Plus that VLAN number, okay? We have, of course, our MAC address of this switch, and we have our timers, along with our aging time, 300 seconds. That's very important. We're still on the same switch. Let's look at VLAN 10. So we're looking at VLAN 10, right? So the priority changed a little bit, right? We have 327.68. System ID extension is 10. So 327.68 plus 10 equals 327.78. Okay. So make sense in your head that the priority is made up of the priority number and a system ID extension. Same thing that we saw in that packet capture. Okay. All right. So remember that for the exam, right? So what we're doing, right, what the switches are doing is saying, hey, who has a better bridge ID, right? And so if I pull up switch 2, okay, and we do the same verification command for spanning tree, okay, and we say, hey, right, we say this, and let's just focus on this for now. We have a bridge ID of 327.69 for VLAN 1. What does the root ID have? A priority of 327.69. So our priority is the same. What do we have to do next? Now the switches, right, within its control plane is going to say, I can't have two root switches within my spanning tree topology. I need to go to a tiebreaker, right? And this is BPDU being sent between two switches, trying to make an election. So it's going to say, all right, let's go to the tiebreaker, which will be the system MAC address. We're going to look at that MAC address. Whose MAC address has the lower value or the better value, so to say? When we talk about a better value, you guys always want to remember, and this is the Easter egg. For layer 2, lower is better. For layer 3, higher is better, right? So this is switch's 1 MAC address. This is switch's 2 MAC address. The difference is 1 at the end of octet number 2, okay? With 1 being lower than 2, switch 1 wins, has the root switch, okay? All right? Hopefully that makes sense, right? So when electing it, and once it sees the bridge ID, once it sends off because that bridge ID and it says, hey, there's a superior bridge ID, okay, with a better, more specific, with a better bridge ID than I am, right? I'm gonna let them be the root switch, right? This is what happens. So again, first we look at the priority. If there is a tie, if a tie occurs at the priority portion, right, that tiebreak is going to be the lowest MAC address. Okay. All right. Let's clear this out. All right. Let's keep going. So we spoke about that. We spoke about electing the root bridge, right? Let's talk about, let's discuss choosing each switch's root port, right? I know we spoke about it before, right? But just as a review, right? The second part of what happens, right, within spanning tree conversions, right, is when each, because again, this is the root switch. We'll go ahead, I'll do my fabulous drawings again that I do. That's a great king sign. Um, so now each non-root switch, which will be switch 2 and switch 3, right, they need to go ahead and switch their root port, right? And this is the port that's facing the root switch that will always be forwarding traffic, right? What is the root port? The root port is the interface that has the least cost to reach the root switch. Okay. Let's put values on these links, right? Let's say this is a cost of 4. This is a cost of 4. This is a cost of 4. Okay. So from switch 2 perspective, to get to the root, right, I can go ahead and go through gigabit 0/0. That's a path of 4. If I want to go through switch 3, well, I can go through gigabit 0/2 to get to switch 3, then the switch 1. That path cost is 4. Remember what I told you. Great way to remember. Layer 2, lower is better. So 8 versus 4, which one I'm going to choose? This path right here. Okay? So with that being said, that is how a root port is selected. Okay? Now, does that mean, is it possible to have this? Absolutely. And guess what path the switch is going to choose? Has its root port. This. Because see, this is an algorithm. This is a calculation, right? It's not about who has the shortest link to the root switch. It has who has the best path cost, the best cost, right? Okay, towards the root. So if there's advertisement from switch 3 saying, hey, to get to switch 1, I have a root path cost of 1, right? And this this link has a cost of 1. So it takes me a path cost of 2 to get to switch 1. I can absolutely go this way. Okay. Again, it's not about how if you have a direct link, it's about path costs, right? So please remember that being a network engineers. Okay. All right. So now that we've talked about calculating the root port, right? Um, we need to talk about the tiebreakers that come into play whenever we're electing that root port, right? So let's say, right, choosing the root port, right, we need to go ahead and see a few things, right? So to choose the right path, right, first we need to go ahead and see if there's the same cost, right, same cost, what have you, to reach the root, right? Maybe 4 this way and maybe 4 that way, right? We're going to choose based on the lowest neighbors. This is the first tiebreaker, the lowest neighbors bridge ID. Okay, right? If there's a tie there, the next tiebreaker is going to be based on the lowest neighbors port priority. And then if there's a tiebreaker there, choose based on the lowest neighbor's internal port number. You will need to know this for the exam, okay? So please make sure you study. All right, read this chapter, chapter 9, very deeply. Please practice it on a piece of paper, so it can make sense to you. Okay. All right. So, what's the final step whenever we're going ahead and we're choosing, we're doing spanning tree conversions? We need to go ahead and choose the designated port on each local area network segment. Okay. So, the switch with the lowest root cost wins the competition, right? To go ahead and become the designated switch or what have you, right? Um, we go ahead and we become the designated switch. One port is going to become, and this will be easier with my pencils. One port is going to become the designated port. Okay, right? And that designated port is forward, right? We have the right. We have a designated port on the root switches, right? Because they're always in a forwarding state, right? These elections are also happening on the non-root to root um, non-root to root connections. Okay, so root port, right? So this isn't going to be a designated port. This is just going to be a root port. Designated port is right here. Is that root switch, right? Um, Same thing. Switch 3, right? We have a root port, right? Non-root switches, right? We need to have an election here, right? And so that election is going to be the same that you guys have seen before, right? First things first, hellos are going to be sent on that link, right? Within those hellos, you'll see the bridge ID, right? You see a pattern here. Bridge ID is going to be examined, right? The priority, right? That system MAC address, right? We're going to check the timers or what have you. Everything is going to be changed. It's going to be checked. I'm sorry. Then the determining factor is going to be the lowest root cost, root path cost, right? To get to the switch, to get to the root switch, right? Once that happens, excellent. I get to choose my designated switch, right? And my designated port for a non-root segment. Okay. So let's finish this. This will be in a blocking state. Okay. And now we have spanning tree convergence. Okay. Um, you guys getting your CCNA or what have you, you guys need to understand the importance of configuring influence, right? Um, on your spanning tree topology, just like how you guys just saw how I was able to change the port cost, right? You know, how I was able to have, let me go ahead and clear that. I was able to have 4 here, but also have 1 here. This is influencing your spanning tree topology because you want the algorithm to tune based on your configuration, right? Again, you know, we can look at the bridge idea, what have you, but we can, of course, everything is always going to fall to the path cost. Okay. So, engineers, you can go ahead and do that. But one thing you will need to know for the exam is default port costs according to the IEEE. Okay. So, let me do that. Let me pull this up for you guys so you guys be able to see. Okay. All right. So, there are costs, and you can take a screenshot. There are costs that you guys would need to memorize, understand, or what have you. Okay. So, different speeds. Okay. Here are the costs. Okay. Right now, of course, nowadays we see 1 gigs, see 10 gig, but we have errors here. Okay. One major difference. Okay. Is that the cost change, right, after 2004. And you guys will learn about this soon. Okay. You learn about what this means soon, right? Just think of these as the IEEE cost and memorize these. All right. Um, to add some technical background about around this, right? Spanning tree have what they call short mode and long mode. Short mode, it uses the 802.1d values for, port cost. Long mode, it supports all the way up to a certain amount of terabytes, okay? Terabyte speeds, right? With that, we couldn't use old IEEE port costs because if it stops at 2, it's every other path will be the same, even if we have higher speeds. So we may have faulty spanning tree algorithm um, paths, right? When we know we have, faster paths. So if we look at this, right, we may have a 10 gig link, but then we have a 100 gig link, but it has the same cost of a 10 gig link. Now it's being has a superior link. We don't want to do that, right? So you being the engineer, you can go ahead and implement long mode. Short mode and long mode, as I reviewed it, is something that you will not need to know for the exam, but you will need to know these port costs. So please make sure you study it. Test out in your lab, okay? Um, do all that you need to do, okay? Um, with that being said, we're going to stop here, right? This next section is we're going to go ahead and talk about timers, right? That you guys can know so that you guys can go ahead and manage convergence. Convergence is a term that you guys need to um, lock into your heads, right? When we talk about spanning tree, right? Um, and of course, I think we're gonna be able to go ahead and jump into rapid spanning tree concepts in this next section as well. Um, with that being said, guys, you guys have a great night.
Thanks, David.
All right,
Good night.
bye.